vectors written in what we call a linear combination of these unit vectors. These unit vectors here, I represents the vector 1, 0, so that is the unit vector there on the x-axis, and j is the unit vector 0, 1. It is the unit vector on the y-axis. So obviously they have length 1, thus being called unit vectors. So I always corresponds to your x component, and j is always going to correspond to the y component. Now, I don't think that that's too difficult to remember since they are in alphabetical order. Just like x, y is in alphabetical order, I, j is in alphabetical order. So I goes with the x component, j goes with the y component. The I here is not to be confused with the imaginary number I. Notice it will always be bolded to kind of help separate the two from each other. So we're not talking imaginary numbers here, but they do use the same letter for that x component unit vector. All right, so let's look at an example here. U is the vector with the initial point 2, -5 and terminal point -1, 3. Write U as a linear combination of I and j. So we need to find the components of U first. We need to do terminal minus initial, so -1 minus 2, 3 minus -5. Simplify that out, so that's -3 and +8. That is U in component form. So as a linear combination, all you do is take the x component and put it in front of the vector I, and we take the y component and put it in front of vector j. So -3i plus 8j says the same thing as the component form -3, 8. Okay, let's do another one. Initial point -2, 6, terminal point -8, 3. So vector u in component form is -8 minus -2, 3 minus 6. So that would be -6, -3. So you take the x component, put it with the I, -6i. Since the y component is negative, we'll do -3j. Technically, it's the same thing if you do plus -3j, but just know that by convention, it's going to have that minus instead of plus and negative. Okay? It's literally as easy as that. Okay, it's just that notation that tends to throw people off when the i's and j's get introduced. Any questions?